All right, so this one says consider the functions f and g. And then they want us to know, they want us to do f times g of x. So they wrote it this way, but really what they want us to do is f of x times g of x, okay? Well, when you do rational expressions, so let me write this out. So f of x times g of x, we're going to write f of x in blue. So we're going to say x squared minus 16 all over x squared plus 3x minus 10. Now, we're going to come back to this in a second. There are only two types of domain restrictions. In all of the math and all of the functions, there are only two types of domain restrictions. One, you can't take the square root of a negative number. Two, you can't have 0 in the denominator of a fraction. So when they say x is equal to negative 5, or x cannot equal negative 5, and x cannot equal negative 2, that tells me that those values, if I plug those in the bottom here, they're going to make the denominator equal to 0. That's important because we're going to factor the denominator in a second. So then the next thing is let's deal with g of x. So now that's going to be multiplied by g of x, which is x squared. So I'm going to write that in red, minus 4 all over x squared minus 7 x minus 12. So same thing, they've got x cannot equal 3 and x cannot equal 4. Now what that means, first thing that we're going to do before we multiply this out is we're going to do a thing that we call prime factorization. Now these problems are always rigged up so that when you factor them, stuff cancels out. So I know that x plus 4 times x minus 4 equals x squared plus 4x minus 4x minus 16. In other words, my numerator, this x squared minus 16, is the same as x plus 4 times, why is this? Times the quantity x. Well, let me put that in blue. So if I do the prime factorization, if I find the factors of the numerator, it breaks down to x plus 4 and x minus 4, right? Because over here I've got a plus 4x and a minus 4x. Those cancel, and I'm left with x squared minus 16. Now on the bottom, I already know, but we can double check it. It's going to be negative 5, or it's going to be the opposite of this. It's going to be 5 and negative 2. In other words, this is going to be x plus 5 and x minus 2. So if I were to multiply this out over here on the side, and I say x plus 5 and x minus 2, I get x squared, positive 5x, a negative 2x, and then negative 10. Okay? And where does that come from? Well, if I plug in, it tells me I can't have negative 5. Well, why? Because if I were to plug in negative 5 right here for x, that would equal 0, and that would 0 times whatever this is going to be 0, and you can't have 0 in the denominator. So now, on my next fraction, x squared minus 4 is the same thing. That's what we call a difference of squares, so that factors into x plus 2 times the quantity x minus 2, right? And we can double check that as well. If I multiply that out, x plus 2 times x minus 2, I get x squared plus 2x minus 2x. These cancel, and then I get negative 4. Now, up for that one, we're told that it can't equal 3 and it can't equal 4, which lets me know that it's going to be x minus 3 times the quantity x minus 4. We could double check that real quick too by multiplying it out. X minus 3 times the quantity x minus 4. X times x is x squared. Negative 3 times x is negative 3x. Negative 4 times x is negative 4x. Negative 4 times negative 3 is a positive 12. These combine, and that gives me my negative 7x. Oh, wait, did I write that down wrong? I'm sorry, this is a plus 12. I didn't copy it right, but it's a plus 12. See? Plus 12. So anyways, that's the factorization. But now here's an interesting thing. Negative, or x minus 2 divided by x minus 2 is just 1. 1 over 1. Anything divided by itself. And what I'm thinking is, I'm thinking in terms of, like I'm saying x minus 2 over x minus 2, that equals 1 over 1, because they're the same thing. Anytime you divide something by itself, you get 1. There's some other stuff that could cancel too. So I've got x minus 4 over x minus 4, that equals 1. Okay. So then what I'm left with is x plus 4 times x plus 2. Ooh, I'm running out of room here, so I'm going to transpose this up to the top. So then I'm going to take this, and up here at the top I'm going to say x plus 4 times x plus 2 all over this times this. So that would be x plus 5 times x minus 3. Now, if you were to put that in the grid, what you actually end up with is you're going to get x squared plus 6x plus 8 all over x squared plus 2x minus 15. Okay? And then remember, in the denominator, x cannot equal, what makes this equal 0? Negative 5. And what makes this one equal 0? Positive 3. So x cannot equal negative 5, and x cannot equal positive 3. So this is the answer right here. We got to get the right domain restrictions, because when you do the multiple choice, it gives you the wrong domain restrictions. So that's an important part of it too. Okay, so that's it on that one. Whew, that was a lot of work.